Welcome to Zero Hours. If you're fascinated by science, space, and the greatest mysteries of our universe, you're in the right place. Today's journey begins with a question that has puzzled humanity for over a century. Could Einstein's theories one day lead us to time travel? Let's find out. Imagine waking up tomorrow, only to discover that everyone you know has been dead for hundreds of years. Your family, your friends, your entire world, gone. Not because you slept for centuries, but because time moved differently for you. It sounds impossible, like something from a science fiction movie. But according to modern physics, time itself doesn't always move at the same speed. And the scientist who changed everything was Albert Einstein. Interestingly, Einstein never designed a real time machine. He never built a futuristic device with flashing lights or spinning metal rings. Yet the equations he wrote over 100 years ago completely changed our understanding of reality. Those equations revealed something extraordinary. Time is not fixed. It is not the same for everyone. Instead, time can stretch. Time can slow down. And under the right conditions, time can even separate two people living through the exact same moment. Imagine two perfectly synchronized clocks. One stays safely on Earth. The other is placed aboard a spacecraft traveling close to the speed of light. For the astronaut, only a few years might pass. But when they finally return home, decades may have passed on Earth. Everyone they once knew could already be gone. This strange phenomenon is called time dilation. And unlike many science fiction ideas, time dilation is supported by Einstein's theory of relativity and has been measured in real scientific experiments. Even satellites orbiting Earth experience tiny differences in time because of their speed and gravity. Without correcting those tiny differences, modern GPS navigation wouldn't stay accurate. That means every single day, your smartphone is quietly using calculations based on Einstein's ideas. So if time can slow down, one question naturally follows. Could we ever control it? Could humanity someday travel into the future? Or even the past? To answer that question, we first need to understand the incredible universe Einstein revealed. If time can slow down, then the next question becomes even more incredible. Can it actually be bent? According to Einstein's general theory of relativity, gravity doesn't simply pull objects together. Instead, gravity bends the very fabric of space and time. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet bends under the weight. Now roll a smaller ball across it. The smaller ball curves toward the larger one. Space and time behave in a surprisingly similar way. Massive objects like stars, neutron stars, and especially black holes, can bend space-time so dramatically that time itself flows differently nearby. The stronger the gravity, the slower time passes. This isn't just a mathematical trick. Scientists have confirmed these effects using incredibly precise atomic clocks. Even a clock placed at a different height on Earth measures time slightly differently because gravity changes with altitude. Now imagine the most extreme object in the universe, a black hole. Its gravity is so powerful that even light cannot escape once it crosses the event horizon. Near a black hole, time slows down dramatically compared to someone far away. An astronaut orbiting safely outside such a black hole might experience only a few hours, while years, or even decades, could pass for people back on Earth. That's one reason black holes fascinate scientists. Not because they're magical, but because they reveal just how strange reality can be. Then comes another extraordinary idea, wormholes. Think of folding a piece of paper. Two distant points suddenly touch. Instead of traveling across the entire page, you simply move through the shortcut. A wormhole is a similar concept. A hypothetical tunnel connecting two distant regions of space, and perhaps even different moments in time. If such a tunnel existed, and if it could somehow remain stable, it might allow someone to cross unimaginable distances almost instantly. But there's a problem. No one has ever discovered a traversable wormhole. Some equations suggest they might be possible, but keeping one open could require forms of matter we have never observed in nature. So today, wormholes remain one of physics' greatest mysteries. Still, every new discovery about gravity, black holes, and the universe brings scientists one small step closer to understanding whether time travel could ever move from imagination to reality. But even if we built a machine capable of bending time, would it actually be safe? Or would changing the past create impossible consequences? That's where the greatest mystery begins. But even if humanity somehow discovered a way to bend time, a far more dangerous question would appear. Should we use it? Imagine traveling back just 10 years. You warn someone about a disaster. You stop an accident, or you change a single decision. At first, it sounds like the perfect solution, but every choice creates consequences. If one event changes, thousands of others may change with it. This idea is known as the butterfly effect. A tiny action today could completely reshape the future tomorrow. Now imagine going back even further. What if you accidentally prevented a scientist from making an important discovery? What if history itself changed? Would your present still exist? Or would an entirely different timeline replace it? Physicists have debated these questions for decades. One famous idea is called the grandfather paradox. Imagine traveling into the past and preventing your own grandfather from ever meeting your grandmother. If that happened, you would never be born. But if you were never born, then who traveled back in time? It creates a logical contradiction with no simple. To solve this mystery, some scientists have proposed the idea of parallel universes. Instead of changing your own past, every decision could create a completely new timeline. One universe continues exactly as, while another follows a different. Then every possibility could already exist somewhere in the multiverse. A universe where dinosaurs never disappeared. A universe where humanity never evolved. Or perhaps, a universe where time travel was successfully invented. As incredible as these ideas sound, there is still no experimental evidence proving that people can travel into the past. Modern physics allows us to understand why time can slow down, but traveling backward through time remains one of the greatest unsolved mysteries in science. Every new discovery brings us closer, yet the biggest answer still lies somewhere beyond our current understanding. And that raises one final. If Einstein's equations changed our understanding of time forever, could they one day lead humanity to the impossible? More than 100 years have passed since Albert Einstein introduced his revolutionary theory. And even today, scientists around the world continue testing his ideas. So far, every major experiment has confirmed that his understanding of space and time was remarkably accurate. Yet one mystery remains. Can humanity ever build a true time machine? Right now, the honest answer is, we simply don't know. Our technology is nowhere near powerful enough to control gravity the way Einstein's equations describe. We have never discovered a stable wormhole. We cannot create the unimaginable amounts of energy that such a machine might require. And we still don't fully understand how gravity works alongside quantum physics. But history has taught us something important. There was once a time when flying across the sky seemed impossible. There was a time when people believed reaching the moon would never happen. There was even a time when carrying a computer in your pocket sounded like pure fantasy. Today, those impossible dreams are part of everyday life. Perhaps time travel is another dream waiting for its moment. Or perhaps nature has built invisible rules that no civilization can ever break. Maybe the past is permanently locked, while the future can only be reached 1 second at a time. Whatever the truth may be, Einstein gave humanity something far greater than a machine. He gave us a new way to see reality itself. He showed us that space and time are connected, that gravity can bend the universe, and that the impossible often becomes the starting point of discovery. So, the greatest time machine Einstein ever created wasn't built from metal. It wasn't powered by electricity. It was built from ideas. Ideas that continue to inspire scientists, engineers, and dreamers across the world. Maybe one day, someone will solve the final puzzle. Maybe one day, humanity will step through a doorway into another time. Until that day arrives, the time machine Einstein never built remains one of the greatest scientific mysteries ever imagined. If you enjoyed this journey through science and the unknown, subscribe to 0 Hours for more mind-bending mysteries about space, time, black holes, and the secrets of our universe. Because the next mystery might change the way you see reality forever. If you enjoyed this journey through science and the unknown, don't forget to subscribe to 0 Hours. Every week, we uncover the greatest mysteries of space, time, black holes, and the universe. Because the next mystery might completely change the way you see reality. Ye complete hack.